Okay. Then welcome everybody to one of the last sessions here at DevOps 2022. And we are going to talk about record types and how that helps us with building better domain models. And the good message is I'm the last person between you and the weekend. Okay. Who is that last person between you and the weekend? Here you can see my name is Henning Schwentner. I'm a Java developer, but I also use other languages, so please don't throw tomatoes at me. Talking about these records, we will see that's something where different languages are also interesting. I'm a proud dad, and I work as a coder, coach, and consultant at a company that's called WPS. And coder, coach, consultant, that means when I'm lucky, I get my hands on the keyboard. But most of the time, I work with teams on their big legacy piece of software that is monolithic and that needs new structure, that needs new modules that maybe should go into a direction of microservices. So if you are wrangling with your monolith and need help, then give me a call. Also, I'm the author of this book here, Domain Storytelling, that can help with understanding a domain on the one hand and also splitting the monolith on the other side, and also finding the data types that we will then later use as record types. And I'm sorry, but I have to start with a kind of sad truth here, and that's sad for us developers, and that is software is not an end in itself. What does that mean? Well, software is built for us, right? For tech people? No. Sorry, it's built by us, yes, but it's built for somebody else. It's built for business people. It's built for users. Some of us have users that are also tech people. Some of us build compilers or IDEs or stuff like that, but most of us, well, we're not building stuff for developers, we're building stuff for business people, and that means we have to understand these guys and what they are doing. Because that's what our software should help afterwards. So that means we have to understand the work of our users, so we can then build software for that. So that's the general idea. And that means it's a good idea to build the software not somewhere in outer space, but in a way that is closely connected, that it's deeply rooted, as we can see here, in our domain. So in what our users are doing, our business people are doing. So we have to understand what they are doing, and then we can take that knowledge and build software from that. So this picture shows this. Here, this is the work. A woman using some air pressure hammer to put bolts into a big piece of steel here. That's her real work. And this here is a reflection of what she's doing. And that's what we are going to do with software. We are building a reflection of the real life. We try to understand what's happening in the real life and then modeling that real life in the software. That's what we're doing. So programming is model building, in a way. We're building a model of the real world in the software, a model of the domain, so that's why it's also called a domain model, this thing that we're building here. And then there are some basic rules here, easy rules of thumb in the end. So one thing is that the objects from the real world, they will turn into objects in software. So the things that we find in the real world, we make things out of them in the software. And also interesting, the actions in the real world, what is done, what our users are doing with the objects, with the things, they turn into operations in software. Operation in Java means a method. Or when you use other languages, then it can be functions or procedures or stuff like that. In Java, it's a method. So rule of thumb, objects from real life turn into objects in software. Actions in the real world turn into operations in software. Well, that's basically the idea of object orientation, right? We all learned that when we were learning programming. So that means to build object-oriented software, we have to understand the objects in real life. And let's look at an example here. Let's look at an example that we all might know. Let's look into the domain of banking. And let's look at a process, how a typical bank customer is using his bank or their bank. So we have a customer here, and in the first step, the customer opens an account with an IBAN at the bank. And the second step is the customer deposits an amount of money onto that account that they just opened. And then at the end of the month or at the end of the year, the bank will pay the interest for the amount that is on the account into the account of the customer. And then maybe later the customer withdraws another amount from that account. So that's a very coarse-grained process of how a bank customer can use a bank account. And what we can see here is we were talking about bank stuff. We were not talking about computer stuff, and that's important. We first have to understand the business stuff, the domain stuff, and then later we can build software for that. So we have a lot of words here: account, IBAN, bank, interest, amount, but also verbs like open, to deposit, to withdraw. And all these words, they are interesting for us because they all help us build software, all help us build the domain model. So what you can see here is called a domain story. Domain stories are stories that are told by our users, our domain experts, and while they tell us what they are doing, we are drawing these diagrams to show, did we understand you correctly or what did we misunderstand? Yeah, as we all know, misunderstandings between developers and domain experts, developers and users, they are very common. This is a way to get rid of that. If you're interested in that, look into the book that I just showed you. Okay, so from this domain story or from understanding our domain, we can get these words, we can find these things and the activities that will then turn into our domain model. So I go back to this picture here. For example, we have the bank account here. That's going to be a class, and we have opens and deposits. Those are going to be methods. So that's the rule of thumb that I showed you earlier. We can use that and apply it directly to these domain stories here. So work objects turn into classes, activities turn into methods here. And so it's clear that we have a class account and methods open and deposit and withdraw. And then we have things like the amount here and the IBAN. Well, they are not things really, right? They are not objects in the sense that we can take them into our hands, we can touch them. So they are interesting for what we are looking at today. But first we have to look a bit into history, where these ideas of object orientation, of taking objects from the real world, making objects in the software, where does this come from? And the first object-oriented software was invented by these two guys, Ole Johan Dahl and Chris Nygaard, Norwegian computer scientists, and they created a programming language that's called Simula, and we can hear from that name that was made for simulation, and that's what we're doing with these object-oriented software. We're simulating the real world in the sense of we're taking the objects from the real world and make objects in the software out of them. And then one of the next object-oriented languages was Smalltalk, and Smalltalk is an extreme object-oriented language, and the Smalltalk guys, they said, well, everything is an object, and that's why we built our language like that. Everything in this language is an object. And after that, all languages had to answer this idea of, is everything an object, or other things as well. So it started with Simula and Smalltalk, but C++ and Python and PHP and later Java and C# and even later TypeScript, they all had to answer this question, is everything an object, or do we have other concepts as well? And when we look at Java, then we see, well, Jim Gosling, when he started to develop Java as a language, he also said, well, everything is an object. Also, C#, when that was developed, they said, well, everything is an object. But when we look at the real world, not everything is an object. Well, so that's where DDD, where domain-driven design, enters the place. DDD is something that was conceived in the object-oriented community, and that looked at, well, is everything an object, and do we have different kinds of objects? And Eric Evans, the inventor of DDD, said, well, there are at least different concepts here, different patterns, he calls them building blocks, that we want to look at. Entity, value, object, they are very important for us today, and other concepts as well. So we look at entity and value here, or thing and value. For the things, we said already, we have objects for that, but what about the values? And what you can see here, entities and values, well, there are apples and pears. They are different concepts, and you can try to simulate one concept with the other, but honestly, I think in the real world, we have them both, and in programming, we also need them both. And when we look closely, I said Java has this idea of everything is an object, but not really everything is an object, right? We have int and float and long and byte and char and so on. We have the so-called primitive types, which are not objects. And in the C# world, we also have what's called structs or value types there. C# hackers here in the room? 2 or 3, okay. So we need one, at least I think that's a good idea. We need another rule of thumb here, not only objects and actions. We also need a rule of thumb here for values from the real world. They should turn into values in software as well. And the values that we just saw, these here, they are not enough, because there are only technical values, and we also need domain values here. Look into that in a minute. First, we have to ask the question, what is an object? And I mean object here in a narrower sense, with this DDD idea of entity or thing. So that's the first point. An object is typically a thing, and an object has an identity. That means when I have two objects of the same class that are equal, it doesn't necessarily mean that they are identical. Or if they are two, it necessarily means they're not identical, even if they are equal. So identity is an important thing. Also, objects, they exist in time. So I create an object, and then I can do something with an object, change its state. And, sorry. And at some point in the future, the end of the object will come, and then we have their garbage collection, and that cleans up. So that's the typical life of an object. So an object has a life cycle here. So those are important properties of an object. An object has an identity, it has a life cycle, and it has a state, and that state can be mutable. Not all objects are mutable, but many are. And there are also immutable objects. So those are the objects. And what is, on the other hand, a value? Well, a value does not have an identity. So a value is not a thing. A value is more an idea, something abstract, an abstraction as a value. And values exist out of time, in a way. So they are timeless, and they are never changing, immutable. So we are saying a value is something that has no identity and is immutable, cannot change. So we just saw in Java we have these 8 primitive types which are values in the sense. So the value 3 of type integer doesn't have an identity and is not mutable. When I have a variable, then I can change the state of that variable from 3 to 4, but the abstract idea of the value 3 is not changing. 3 itself is not changing, it's just the variable that is changing. Okay, so that's maybe a bit abstract. Let's look at an example. What is a value? So these here are couples, and what's the abstraction of couples? Maybe that's the value 2. All couples are made of 2 people, so 2 is an abstraction of this thing. That's the Platonic idea. So if now one of the couple chooses they are going to divorce themselves, well, this doesn't change the abstraction 2. This doesn't change the abstract idea of 2. That will still be the same. And even if all couples are going to split, and there is no couple anymore, we still have the abstract concept of 2. So that's the philosophical view. For us, of course, more interesting is the concrete programmer view on that. And how are values and objects now implemented in our languages? So in Java, the values, they are, the objects, sorry, in Java, the objects are made by classes. So we have these little cookie forms here, and that's the class. And when we put it on cookie dough, then we can get the instances, that's the objects out of it. Huh? At least if we think as our software is cookie dough. And here we can see this is the class, and these are the objects, and the class is the type that defines the type. That's the idea. And those are concrete instances of that. And if one of the instances or 2 of the instances are changing, well, the others are not changed because they have an identity. Here they were equal, but they were not identical. So now I can say, well, change your state star number 3 and change your state number 4, and then they are changing here. And also, if I change one of the stars like this, and then, well, the object is not in anymore, then the rest of the object still is there. So we have one type and can have several instances of that. How is the identity of an object built in Java? Well, that is done by the reference. In Java, all objects are made from reference type, so we never have the object directly in a variable. We always have a reference. So that means here we have 2 equal objects which are not identical because you can see here the reference points to different points in the memory. So this here is the same object, then we can say these 2 references point onto the same thing. So this is identical to itself, obviously. These are 2 equal things, but not identical things. Okay. Sorry, I have to jump over that. So that's objects. How about values? What can we do with values in languages like Java? We have the built-in value types. We have the primitive types. In Java and C#, there's also an answer that's simple types. Things like int, double, boolean, character, and so on. In Java, it's exactly 8 primitive types that we have. And, sorry to jump over that. And that's nice that we have these 8 types, but how about user-defined value types? What if we need more values? What can we do then? Well, there's things like string and local date that are actually objects, but that behave like values, right? A string cannot change, it's immutable. And it also has no identity. If I compare two strings which contain both the characters hello, well, then they count as equal, right? So we say these objects, string and local date, they behave like values. And objects that behave like value types, they are built in Java with value-based classes. They were there right from the start with Java 1.0. But they are, well, kind of a crutch here. In .NET, we have classes with value equality. Okay. So let's look more closely at the values in Java. These in double Boolean character, we have the built-in types, yes, but we cannot have something like unsigned or complex. We don't have other technical types. Plus, we also cannot have domain value types here. IBAN, postcode, and amount. Not real value types here. So when we look at our bank example with our money amount, yeah, well, then we have to use this crutch here, this value-based class. And how is that working? Well, we are using a class, we're using objects to simulate values. And as you remember, values, they don't have an identity, and values, they are immutable. So that's why we say, well, a value-based class that can only have final fields. Final fields because immutability. That also means we cannot have methods that change the state because immutability. And how do we get the no identity thing? Yeah, well, we override equals in a way that it does not depend on identity. That typically means field-wise comparison. And when we override equals, we always do what? Yeah, we always override hash code, of course. So that's a value-based class. That's what we have in string and local date. And that's what we have to do until Java 13. We have to use value-based classes when we want to build or when we want to have values in our domain model. And with Java 14, starting with Java 14, we get the new record types, and they can help us here because they make our life easier. They will help us at least save boilerplate code. And also at some point in the future, there will be real value types, but well, we don't know yet when this point in the future will be. Okay. Sorry, this is values in C#. I'm going to jump over that. If you're interested in how this is done in C#, then come to me after the talk. Okay, so why do we want these value types, these domain value types? Why is that important? Why aren't int and string enough? I mean, why aren't these built-in types enough? So let's look at the banking example and see more concrete which kind of problems come from that. So in our domain story, we found that one of the most important concepts in the bank is, of course, the account, the bank account. And does the bank account have an identity or not? This is an entity or a value object. Does it have an identity? Yes, yeah, okay. Does it not have an identity? Okay, yeah. What is the identity of that bank account? The bank account number, the IBAN in our example. So let's make that an entity in the sense of DDD. So let's write an annotation at entity here. And beware, this is not JPA entity. This is DDD entity. I'm using a small framework here, which is called JMolecules. Some people might know that. If not, Google it. It's a small annotation library, so we can use, we can make explicit which pattern we are using in a certain class. Okay, so, and what's the first idea for an account? Yeah, well, a bank account has a balance. And don't take a picture now, because this is what I want to show you. You shouldn't do with this red cross. So what is a bank account? A bank account has a balance. Well, let's put a getter and a setter, get balance and set balance on it. So why did I put the red cross here? Because this is what's called an anemic domain model. And this is, of course, dangerous, because with a setter here, you can do everything. The account balance can be set to any value. And, well, that is not how bank accounts are working, right? At least my bank account is not working like that. And when we think about the domain story that we saw earlier, then we saw there were no verbs set, no activities set, but we had the activities deposit and withdraw. So a good domain model is more something like this, where we have operations with domain-specific behavior and domain-specific names. So this is real object orientation. This is anemic. This is object orientation. Well, kind of. I try to, but I don't do it real. This is what we had. Not what we want to have. Not only fields here, which are have domain names, but also the methods, the behavior that comes from the domain. And if we have something like this, deposit and withdraw, then we can do something like this here. We can check on the method withdraw that it's an amount that is allowed. So it has to be an amount that is smaller than our balance, or else we cannot withdraw it. So in this way, the class can ensure that it is always in a valid state. Yeah, of course. And here it's done with exceptions. Of course, it can also be done with assertions. I'm using assertions here on the slide because that's shorter. So we assert amount is smaller or equal to balance here. Okay, so that's great, having these entities here. But this amount here, is that in euro or British pound or some other currency? And can I withdraw a negative amount? What does that mean? And well, yeah, that's where domain values come into play, where we want to have value types that express concepts from the domain as well. So let's build a type for this money amount here. And is that also an entity like the bank account? Or is this a value? Okay, thank you. Two hands up, very good. Okay, so this is a value or a value object in DDD speak. And that, of course, means we have some fields here. We start with an int for the amount and a currency field for the currency. And here you can see currency. Well, that again is another type, another value type. So we are introducing more and more types now. And yeah, well, we have to make these fields final because values are immutable. They never change. And when we make these fields final, then of course we need a constructor and we need to initialize these fields in the constructor. And when we have this constructor, then we can build software that, or code that writes like, okay, new amount 100 euros. This sounds like, well, we are constructing something new, but thinking about values, I said values, they don't have a life cycle, they exist out of time. It's more like we are picking a time, we are picking an amount here. That's why in many implementations you will find something like this here. A factory method with a name of, and now it's not new amount 100 euro, but amount of 100 euro. That reads a bit more natural here. An example for a class where we can find that is local date in the Java standard library after version 8. So we always say local date of and never new local date because the constructor is private. Okay, and then, so then we have this immutability here and also a lot of boilerplate code already written. And now we go on. We also want to have the no identity stuff. And we do this by overriding equals. And then we are doing a field-wise comparison. So we are comparing this amount to that amount, or this amount to other amount, and currency to other currency. And of course, this implementation here is not something that you should use at home. It's not null safe. But as you all know, a good equals implementation is this long, and it didn't fit onto the slide. And of course, when we override equals, we have to override hash code as well. And our class gets longer than it does fit on the slide here. Okay, and that's where we are happy that we have records now today after Java 14, because we get a much smaller syntax for basically the same. We can say something like this here: public record amount, int amount, currency, currency. And that's the same as this here. So it's kind of syntactic sugar, because all this stuff here is generated. So equals and hash code is generated, and these fields are automatically private. That's also, but they are automatically final. That's what I want to say. Okay, so now it's much easier to build more expressive domain models, because this year no programmer has enjoys writing these long things for building the atoms of our domain model. So this is for the amount, but for the currency here we have to do the same thing again, and for the IBAN, which is another value object, again and again and again. That's why many Java code bases suffer from what's called primitive obsession. So there are classes, yes, but these classes, they only have fields of type int and string, and no real values no real types that come from the domain. So this is going to be a lot easier with records here. And, oh, sorry, this is the German variant of the slide. So what we can do with our value types is also to add behavior from the domain. That's interesting. So for example, we can put an add method here on our class amount, and now we can add another amount to this. That is better than using a naked int, because to a naked int I can add everything, a length or a weight or whatever. Now I can only add amounts to amounts. So we are enforcing the knowledge of the domain by using the compiler here. And what you can see here is using this amount of, because we cannot change this amount. Everything is final, it's immutable. So we are returning another amount here. And what you can see here, well, we are using this currency here. Is that good? Well, maybe we need something like this here. We want to have contracts that enforce our preconditions. So we say, well, we can only add to amounts that have the same currency. Because when I add 100 euros to 100 British pounds, what should happen then? Well, we don't know. Okay, so we bring more expressiveness into our domain model, and we bring also more safety into the domain model, because this domain model, this domain code will help us not make mistakes as programmers with this thing. Okay. When we are using record types, we can do the same. Of course, this is much shorter now. We still have this amount and amount currency here, and then we put the add method there, and the same currency method. We add that here as well. So still not much boilerplate code with these records here. And talking about this add method here, that is where operator overloading gets interesting, which we don't have in Java. But for example, in C#. Okay, so now record types help us. but only a bit. And I want to show you why I think I'm going to be even more happy when we have real value types. Okay, so this is the but. Record types, they save us from a lot of boilerplate codes, so it's easier to write more expressive domain models, but they are still reference types, not value types. So that means when we have a variable of a record type, we still have something like this here. We have a reference, a pointer to somewhere in the memory. And that means equals is working, yes, but the operator equals equals is not working as expected. Because these things are not identical, because they are still objects after that. So we cannot pass them by value. We can only pass them by reference, because we never have the object, we never have the record, and hence we only have a reference to that. And that also means that it uses a lot of memory, because when we have a value, it's typically a small thing like this here. We have the money amount with one int and one string. Plus we have the reference here. And the reference on a modern system is, of course, 64 bits. And we have to do the dereferencing here, so that costs performance and that costs memory. And so it would be better to go from here to there, right? Not having a reference anymore, but having the value directly in the cell here. And that's what is tried with these value types. And it gets even worse if we don't only have one value here, but if we have several values, if we have an array. So this is how an int array looks like. The values are directly in the cells, 3, 5, 10, 5, 0. But when we have an object array, and records are objects in the sense we have something like this. We have an array of references, and they point to somewhere in the memory. And they point to somewhere in the memory. It's not that they are nicely packed. So that's why I'm looking forward to have real value types with Java version, who knows? Project Valhalla from Oracle, they are working on that. Okay, for the time being, what's the conclusion? One thing that's important to remember is values and objects, those are different kinds of animals. Those are different concepts. We have records in Java which make our life better, starting with Java version 14. Real value types, they are still to come. And then we can have the cake and eat it too, because we can have an expressive domain model and also even better performance. And yeah, so that's something that is still under construction. And talking about Java 14 or later, who is on Java 8? Okay, value-based classes, sorry. Who's on Java 9? Who's on Java 11? Okay. Who is on Java 14 or later? Awesome. Okay, so there are quite some people that are able to use this stuff here. Okay, if you are interested in further reading, then Project Valhalla, that's the project that Oracle is building the stuff. Domain storytelling, if you're interested in that, this is the book. And if you're interested in DDD and domain-driven design in general, then come into my workshop. And talking about advertisement, I always like to advertise something good. So make a blood donation, make a blood donation. Yeah, that's what I want to do. Your blood is needed, especially after the pandemic now. And with that, I say thank you. Happy end for Devoxx. That's it. Thank you.